Inshallah, this is just a disclaimer. Inshallah, this workshop will be in English. So, for Arabic speakers, you can attend the other workshops today, inshallah. My name is Nawaf Al-Fadl. I'll be talking briefly about the team and also the compliance engine Bimlins. So we have today engineer Muhammad and also engineer Tamer, and also we have engineer Bilal, who will be taking over the architectural part, and also engineer Zaid, who will be taking the structural part of today's workshop, inshallah. So briefly about the Bimlins. Bimlins is a compliance engine against the Saudi building code. So it checks the designs and the drawings against that. So briefly, when developing Bimlins, we had met, or we did a lot of workshops with a lot of engineering offices to take their challenges and see what how can we improve our engine. Just to make it clear, the engine will take care of the 4 disciplines, inshallah: the architectural, the structural, electrical, and mechanical. For today's workshop, we will have the architectural and the structural. So Bimlins, while we doing these workshops before with the engineering offices, we had the problem that they don't have a standard, international standard. So for Bimlins, it has the IFC for the Revit and also the DXF for the AutoCAD. Should make it more easier for any conflict in the near future. Also, Bimlins has a plugin that helps the designer or the architect or the structural engineer to have a live updates on while they're drawing on Revit and AutoCAD. Also, there was a problem with the regulations. The time of the activated regulations, it's not always clear to the engineering offices. There is no updates before it gets activated. So Bimlins will have a system that notifies the engineering offices for any new conditions or regulations. So this is just briefly about Bimlins, inshallah, and we will have now Mhandis Bilal take over and start with the architectural part, inshallah.
Assalamu alaikum, everyone. I would like to take this chance to welcome you and all the attendees to this workshop. On behalf of the Bimlins team and the Ministry of Housing, we all welcome you to this workshop. Today we're going to discuss the residential part of the design. We're going to handle a villa that is located in Riyadh. We're going to do the architectural and structural design and compliance for both AutoCAD and Revit. We're going to start with the architectural AutoCAD, then we're going to move on to Revit. After that, engineer Zaid will take over, and he's going to do the structural AutoCAD and structural Revit. Just a little bit of elaboration on what engineer Nawaf just said. So Bimlins right now, it takes 2 disciplines. It takes architectural and structural to check against compliance with the Saudi building code. Later on, we're gonna add the rest of the disciplines, which are the mechanical and electrical. Plus, we're gonna add a clash detection test also in the near future. In regards to the types of buildings that we're going to be handling on BIM Lens, right now, it's taking the residential part, the residential group. Very soon, we're going to add the commercial group, and in the next phase, we're going to be adding the mixed use and governmental buildings and charity buildings. As engineer Nawaf said, we met with a lot of engineering offices. We collaborated with high number of engineers. We took their comments, their obstacles that they faced in the first version of the compliance engine, and we took this to heart, and we worked super hard to tackle every single obstacle that they faced. We also showcased our new version of the engine. It tackled a lot of problems. I just wanted to say thank you for all the engineering officers that collaborated with us, because without you guys, this would have been a reality right now. So for the roadmap of BIM Lens, as I said, it's going to be taking more disciplines soon, and it's going to cover more building types soon. We also want to move into covering green buildings, and we want to integrate the Internet of Things, IoTs, in order to include the digital twins and digital twin compliance to the BIM Lens engine. So on another note, BIM Lens, as Engineer Nawaf said, is divided into two parts. The first part is for the compliance check. So basically, we ask for a universal file from Revit or AutoCAD. It's a text file. That text file will help us find all the compliance checks that are required for the specific project. Every project is defined by its location, and every location has a different set of rules. Basically, if your project is on the coastal road in Jeddah, for example, the facade of the buildings, they have certain requirements. So BIM Lens would know where you are, and on that street, for example, it has special codes that we have to follow. It's going to lay them down for us, for the designers to see and to comply with those rules while we are designing. On another note, I just want to elaborate also on the plugins that we're going to be providing on BIM Lens. We're going to be using a plugin for AutoCAD. This is going to help the designer tackle all the issues live as he goes with the design before uploading the files to the government or to the ministry for compliance checks. So basically, at the end, by using the plugin, we can get our files done completely, and before uploading it to the portal to the government, we assure that it's fully compliant, and therefore we can get the building permit issued directly, automated, without any human intervention. That said, I just want to move about the schedule of today's workshop. Just give me a second. I want to share my screen. Oh, since then, this is in Arabic. 1 second. Okay, thank you for waiting. I'm going to share my screen now. Perfect. All right. So this is the guideline manual that was provided to all the engineering offices. This one is in English. It talks about the AutoCAD design of a villa. I just want to go through it quickly, and I want to give you a glimpse about BIM Lens user interface and how the designing offices or the engineering offices would see our engine in action. So the index of this guideline is the introduction, a glossary of architectural compliance terms that we're going to be using throughout the workshop. Types of drawings required, naming of elements in BIM Lens, architecture compliance rules for residential villas or for residential units using BIM Lens and AutoCAD. So this is how we're going to be working today. So before I start with this workshop, I would like to show you the user interface of BIM Lens. Just give me a second to try to switch screen. Okay, perfect. So as you can see, you sign in to BIM Lens. You as an engineering office are we're going to be just uploading DXF files and IFC files to the engine for a compliance check. As I said, I already have a few files ready, so I'm going to upload the IFC file for Revit. This is an IFC file for Revit. The IFC file, by the way, looks exactly like this. It's a text file. It has no drawings. It's just pure text. This is what we need to check for compliance. Basically, by unifying this IFC file, any BIM tool, for example, ArchiCAD, Tekla, Revit can export an IFC file. This is what we need. You are not constrained to use a certain version of Revit or Tekla or ArchiCAD. Anything that produces an IFC file, we will be ready to check. But for now, we are dealing with Revit. We haven't integrated other BIM tools yet, but it's in the roadmap, so please be expecting it soon. Let's go back to BIM Lens. So basically, I just uploaded an IFC file, the text file that you've just seen, and I'm gonna hit تحليل. This is just a compliance check to start. So basically, this is going to take a few minutes. The villa in question, I just want to give you a visual about the villa that we're going to be working on today. It looks something like this. So it's a two-story villa. It's an attached from both sides, and it's an open garage. There's no basement. This is for the structural part and the architectural part only. So this is a villa that we're going to be working on. So now when we are using the AutoCAD files, just visualize this villa. Anyways, let's go back to the compliance engine. So basically, a few things about the compliance engine. For the compliance engine, this IFC file that I just the IFC file that I just uploaded is for the architectural part. So basically, BIM Lens uses a 3D error showcasing for any mistakes that we do. Those are the rules listed here. They're in Arabic right now. So, for example, if I have a mistake here, so the green check is for it's fully compliant. This rule is fully compliant with our villa. This symbol right here, it indicates that this item in the code is not present in the IFC file or the model that we did. For example, this one specifically talks about the guard room outside. In our villa, we don't have a guard room, so it gives me this symbol that it's not there or it's not relevant. The X will tell me that I have a mistake with this specific rule. Let's take this for an example. I did this mistake by intentionally, so I can just showcase it. So it talks about the railing of the stairs. If we can hit this icon here, it can take us to a 3D visualization of the mistake. So designers can pinpoint where the mistakes are in a 3D way. In regards to AutoCAD, we show the plans in 2D, and we circle the mistakes of the object or the space that's in question. So basically here I have a problem with the handrails, and so the handrails of the stairs. So basically BIM Lens can show me that the rule that is not compliant for this specific one is the handrails, and it's just showing me where it is in order for me to go and fix it and look at the rule again and see how what mistake I need to fix in order to get it off the X list and into the checklist. So basically, this is a small brief about BIM Lens. As I said, it currently now takes architecture and structural. So I'm going to go back to the guideline. In the guideline, I said it's like I said, there's an introduction about BIM Lens. BIM Lens right now takes or checks against compliance with the Saudi Building Code. Very soon, we're going to be introducing compliance checks against municipalities of different areas in Saudi Arabia. For example, in Hayel or in Riyadh, there's special zones, special areas. We're going to add all these rules to the engine. So in the AutoCAD aspect of the project, we don't ask the user to draw or design using layers. Of course, you need a layer to start designing on, but as BIM Lens, we don't require you to give us a specific name for a specific layer, or you can work on any layer that you want. The only thing that I want is the blocks that we are going to be defining in this workshop and the attributes that's related to these blocks. Now, our IT team developed a list file. This file is going to be provided to you. The list file will give us a new command, which is called PTA. This command is used to transform a polyline into a block, and it will ask you to name that new block. According to that name, the attributes needed for that space or object basically will give us a list of attributes that related to it. In each object or each space, a related to attribute is added. So basically, we're building relationships between objects and spaces, or spaces and spaces. I'm going to showcase this to you very shortly. In terms of Revit, we use rooms or spaces and attributes. Of course, it's more automated in Revit since it's a BIM tool, and it will give us a lot of automated readings, so we don't have to manually put things. But in AutoCAD, we have to manually put a lot of information in the attribute tables or the properties. So the target users for this workshop are architects, drafters, or engineering consultants. I would like to add also it's for the insurance companies that will be dealing with those projects. The scope guideline is, I just spoke about it, like we use blocks, we use file naming conventions and structured drawings. We're going to be also talking about the submission requirements, how you can export or save the model as a DXF file or an IFC file, and compatibility protocol. So we're going to be talking about that too. The glossary in question is all of these. I'm not going to go through them all. So I'm just going to be talking about the next point, which is the naming of elements. This is a very important factor of the workshop. We have to use, we must use those element IDs. Oh, forgot to translate this part. It's okay. I'll do it now, later after this workshop. So basically, let's give you an example for a bathroom or, for example, a bedroom, which is this one. The element ID used must be A-BR- and then a number will come after it, which indicates the serial number of that room. For example, if we have 4 rooms in a house, the first one would be named A-BR-01, the second one 02, and so on and so forth. every single space and object that we're going to be using in our design has to be named from this list. Otherwise, the BIM lens will not be able to read the important information and carry a check of a compliance engine against the code. So basically, for the compliance rules, I divided them into spaces. So basically, every space has a few rules tied to it. So we're going to be talking about dining rooms and majalis, bedrooms, kitchens, bathrooms, laundry rooms, guard rooms, interior corridors, stairs, mezzanines, entrances, ramps, windows, protective barriers, like height of protective barriers, all these things are included. Waste management, car entrances, open areas, general height requirements. So those are the architecture rules that are divided into spaces that we're going to be following this workshop. To start off, we have to, first of all, introduce the list file. We have to add the list file to our project. So let's go to AutoCAD. I'll show you how. So basically, this file is going to be provided to you by email or by a link to all the engineering offices. You are required to use it in order to do a compliant design. So to start with the list file, we have to do the app load command, hit enter. This screen will pop up and it will you have to choose the list file. I've already done this, but I can choose it again and I can load it. It will tell you it will tell me that list file has loaded successfully. You just close, and now if you type PTA in the command box, you're going to find that that command line is there. So that command will help. This is the most used command that we're going to be using throughout the workshop for transforming the polylines into blocks. As I said, in AutoCAD we use blocks and attributes, and we create relationships between them. So let me just demonstrate what PTA does exactly. So basically, let's say I have a polyline here, and I want to draw a space. Hypothetically speaking, let's say that this is a bedroom. If you look at the polyline here, it says that it's not closed. In order to move on to the next step, every polyline has to be closed. Now, when you're using the polyline icon here, the command, automatically the polyline is not going to be closed. So manually, you have to add yes, as it's shown here in the property panel. Or if you use a rectangle command, it will be automatically closed. If we check here, this one, it's automatically closed. Yes, so we don't have to close it manually. Let's go back to this. So in order to transfer this polyline into a block, what we have to do is write the command PTA and select it. It tells me to select it. I'm gonna now it's asking me to write the name of that space. So as I said, it's going to be a hypothetical example. I'm going to do a bedroom. So from the list, I read that a bedroom should be called BR, and we have to give it a serial number. So I'm just going to give it a serial number of 44. This is a hypothetical example. I just don't want the block names to interfere with the workshop name that I'm going to be using later on. So I hit enter. If I go and select the block is already named ABR0 and all the attributes needed are given here automatically. So basically, BIM lens will know that for a bedroom, I'm going to need those attributes, which are area, height, length, related to, and width. Let's talk about the attributes. The area is automatically given. The height is the architectural height. Basically, since we don't have it right here, so we have to go to, for example, the cross-sectional view and get the architectural height of any space. So in this case, our architectural height is 2.62. So I just go here. I already selected this block, so I would just write 2.62. and the length is given and related to. So the related to, I just want to explain what related to is. We have to build relationships between objects and objects and spaces. So basically, this is a space. This is a confined space, but confined by what? It's inside a residential unit. So basically, if this is a bedroom, I would say this is related to the residential unit. The residential unit is related to the residential or the land area. And the land area is, for example, if it's in a compound, it's related to a compound area. I'm going to show, I'm going to showcase this shortly. So this is just a brief example about this part and the PTA and how these things work. The next step is I have to set the base point. I'm sure all the drafters know how to set a base point. It's recommended if you have like a model on a single plan, just set it in the left bottom corner. The steps to do that is written in the guideline. In order to put the geographical location, we're using GIS with our BIM lens. So basically, we need to know where the project is. Why do we need to know that? Because BIM lens will give us the architectural rules that are related to that area. As I explained earlier, we have to tie up all those relationships. So basically, as I said, if you have a street in Hayel, for example, that requires you to do a certain facade or for the buildings, it will be written in the set of rules to comply with. This will be taken from the GIS. So in order to set this up, we have to write the command geographical location, I think, geographic location. It will ask us to choose for a map being file. So I'm going to take a map. So currently I'm in Riyadh. I'm going to have, if you know the coordinates, the latitude and longitude, you can just paste them here of your project, of course. If not, you can look up your project on the map. This is what I'm going to be doing right now. So I'm currently in Riyadh, and my project is in north of Riyadh. So I'm going to hit enter. I'm going to go to my project. My project is located right here. So this is the villa that we were working on. So I can just drop a marker here and continue. I just want you to see something. So this is where I'm pointing is the north. So the true north is going to be this angle between the true north and this villa. So this has to be calculated manually and added. So we have the longitude and the latitude. We hit next. We have to choose a GIS coordinate system. So in this case, we are using, this is all in the guideline, folks. So you can check it out while you're working. So we're using UTM8438N, and we have to adjust the time. I believe Riyadh is with Kuwait somewhere here in the list. Let me just check. Kuwait, Riyadh, and the units we're using are meters. So we hit next, and now we have to set the true north. You just have to set an angle. It's already done with me, so those steps are with you there. So I'm just going to cancel this command. Moving on, as I said, BIM lens is based on blocks and relationships and attributes. So let's pretend that this model is inside a compound area. So let's define a compound area. As I said, we have to always draw a polyline. So this is a polyline taken from the rectangular command. So it's by default, it's closed automatically. We just have to put PTA in the command box, hit enter, and choose the compound area. Now it's going to ask me to name it. From the list, I have to look up the names. So the compound area is listed as ACA, and we're going to name it 01. Let's see if it's there. So as you can see, BIM lens created or created this block from the polyline, and it's called it ACA01. The attributes needed are length, width, and area. Those are automatically given, so we can move to the next step. We have to name the land area, which is inside the compound area. As I said before, I'm going to choose the rectangle command and draw a polyline. We can choose it, check if it's closed. Yes, it's closed. And we can go to the command line and hit PTA, enter. We have to choose the polyline. I did, and we have to call it. We have to name it. From the list again, we look up the land area, which is A-LA01. Hit enter. We check that if the transformation happened, BIM-Lens magically transformed the polyline into a block with the given attributes. Now, if you can see here, the attributes here, it's missing something. The related to attribute for the land area is missing. So those things we have to put in manually. So as I said, the land area is related to the compound area. So we just named the compound area earlier. So it's ACA01. This way we created a relationship between the land area and the compound area. And we are done for this small part of the project. Now let's zoom in further. Now what do we have inside the land area? We have the residential unit. We have to draw a polyline because it's not a like a defined shape. It's not a regular shape. It's an irregular shape. So we have to use the polyline, and after we use it, we have to close it. So let's start from here. Now we select it. As I said, it's not closed. We have to close it manually, and we have to give it a name. How do we have to make it into a block. How do we do that? We have to write PTA, enter, and it asks us to select the polyline, and we just did. We have to name it as RU for residential unit, and the unique number of it is 01. So there you go. If we select it now and check its properties, we see that we have the area, the length, the width, but the related to is not listed. So this has to be done manually. Engineer Zaid, can you hear me clearly? Because I see that there are some lagging, some comments.
I can hear you, Engineer Bilal. There will be no problem. Maybe they are not installing the WebEx app.
We advise everyone here to install the application instead of going through it through the web browser. This gives you, I think, better experience or better quality with WebEx. Moving on, as I said, the related to has to be entered manually. So we know that the polygon we are dealing with, or the polyline we are dealing with, is a residential unit. So we have to add the relationship. So it is inside the land area 01. We enter, and now this block is this polyline is transformed into a block with the name RU01, and it is with area 96, length 10, and width 10 almost, and related to the LA. So let's zoom in even further. So now we're going to be talking about spaces. How we're going to define spaces, how BIM-Lens will read spaces. We need to follow some certain rules. So basically, we are taking. I'm not going to be doing the whole villa. I'm just going to take one space and a few objects just to showcase how things work with BIM-Lens. Let's start with the kitchen. So let's start with this area, with this corner over here. All right, so the polyline is drawn and it's ready to be transformed into a block. Let's check if it's closed. It's not. We have to close it and hit the command PTA. I see there are some questions in the chat, so we are advised that you keep your questions and send it to us by email so we can respond to each and every one of them. The email is provided to you by by engineer Tamer. He's gonna type it in right now so you can put your questions in email form and send it to us so we can try to answer every single one of you. So moving on, I have to name the kitchen. From that list, the kitchen block has to be named A, KI, and 01. So 01 is for the serial number. Some houses have two kitchens, like a dry and a wet kitchen, so we can name it 01, 02, like AKI 01, AKI 02, and so on and so forth. Moving on now, we chose the kitchen block, and let's go to the attributes. Actually, maybe it didn't. Oh, it didn't. It did. So, PTA. Okay. Okay, so I need to purge my old blocks. Just give me a second here. Because I've done this before and I can't rename with the same. So let's remove the R. Okay, I think now we can use the same name again. So if we hit PTA, go to the polyline and name it AKI01. Let's see. Yeah, it worked. So now the block is called AKI01, and it has a list of attributes that we have to cater to. So the area here, it's given automatically. The height, we have to go back to the architectural height of the cross-sectional drawings, and in this case, it's 2.62, or depending on the ceiling or whatever heights you have. Of course, there will be random human checks to see if you comply with the rules. Sometimes, because there's a lot of manual inputs, the BIMLens team will, after submission, will double check randomly on this information that it has to be put right. And if there's any mistakes, of course, there are going to be some consequences, but we will talk about this later. So the height is 2.62. The maximum length is 4.18, that's given. Width is given. Now, there's a new attribute here, if it's a mechanically ventilated room. In this kitchen, I believe that it is a mechanically ventilated, so it's a Boolean expression. To answer it with 0 and 1, so you type 1 for yes, 0 for no, and we have to give it a relationship. So this kitchen lies inside a residential unit, which is inside the land area, which is inside the compound area. So we have to set the relationship with the residential unit. So this has to be a RU 01, and we are all set. But in the guideline, you will see that the kitchen has a few rules, extra rules. So in order to have a kitchen, you have to have a sink inside that kitchen. We can see here there's a kitchen sink. We have to define it and create a relationship with it, with the kitchen. So how do we do that? We go to the rectangle option. We create a rectangle all around it. So that's a new polyline. We hit PTA, and we give it a name. We select it and give it a name. From the list, from the guidelines, the sink, any sink in the house, it's called a SI. There's one thing that I forgot to mention, that only in AutoCAD, this file also helps the consecutive naming of items. For example, I have so many sinks or so many windows, and I lost count which window it is. So you don't have to fill up the last number. You can just, as you see, write, for example, A dash SI dash and hit enter. BIM-Lens will automatically give a unique number to this object. For example, it gave us ASI02. So ASI01 has been already basically chosen somewhere here in the drawing. So it will give me the next available one. So this way you won't lose track of what's going on here, or the naming of objects. Now we have to set a relationship between the sink and the kitchen. If we go to the sink block is selected. If we go to its attribute, there's only one attribute, which is related to attribute, and this sink is related to the kitchen. We name the kitchen as KI01. So now the kitchen rule that specifies that there should be a sink, that must be a sink in a kitchen, is compliant. Now let's take the window of the kitchen and deal with windows now. Now there are two types of windows. Windows for the washrooms are named ABW dash something like the serial number, and the other windows of the house are AWI. Now this is a kitchen window, so it's a WI type. We write what is it called? A rectangle around it. We draw a rectangle around it and we hit PTA. PTA will give us the option to transfer the polyline into a block. We have to, of course, name it. So this is a window with a WI name. Now windows come with four identifiers. A for architectural, WI for windows. The next one is for the type of window. We see here that this is type 3. So we hit type 3 and we let BIM-Lens give us a serial number, which is the last unit of the naming. So if we hit enter here and choose this block, we see that BIM-Lens named the block AWI0302. So it gave it 2. So basically 1 was already taken, so it started with 2. Now we go to the attributes and we look. The attributes are all empty. What we have to do next is go to the window schedules and let's see which window in question we're using. So it's W3. We go to window W3 and we start filling up this information. So basically closed area is 1.2 times 1.5. Closed area represents the closed area of the glass or the whole window. So if we pull up a calculator and we put 1.2 times 1.5, we will get 1.8 for the area. So 1.8. Height, we see it here, it's 1.5. Opened area, this window slides, as you can see. So it opens by half. So basically half of 1.8 is 0.9. And this is the important part. It's related to, let's get back to it. So the sill height is 1, as you can see from here. And the width is 1.2. Let's see what is this window related to. This window is in the kitchen, so it's related to the kitchen. So we know the name of the kitchen that we just gave is KI01. Now, if we look at the guidelines, we'll see that there's a rule specifying that the area of the window has to be a certain percentage of the area of that room for proper natural lighting or natural ventilation or mechanical ventilation. So for that rule to comply, we just have to fill up this information. BIM-Lens will do the calculations and it will tell you if it's compliant or not. So we are done with the windows. I'm going to do one more window for a kitchen, for a washroom, just to showcase the difference. Now let's jump to what is it called? A door, for example. this is the entrance door. There are two entrance doors, so it's considered as an entrance door. We draw a polyline around it, and we hit CTA. It asks us to name it, to select it, and name it. So to name it, we have to look at the list. This is a door, so from the list we see that it's a DO, and the type is 02. So the windows and doors have four sections in the naming, and not three. The Revit, it's going to start after the AutoCAD. So very shortly, I'm going to start it. If we hit dash and enter, BIMLens will name it automatically. If we look at it, it's called AD 0201. Now we have to look at the attributes. We go here from the door schedule. D2 is the height is 2.4. Is it hinged? Yes, it opens. It's a swing door, so it has a hinge. So yes for hinged. So to say yes, we have to put 1. The length, this is irrelevant. This is related to the residential unit. So ARU 01. Width is 1 meter. And is it an emergency exit? As you can see, it's an entrance to the house, so we have to specify yes. So it's emergency exit, yes, and we're all done with the door. Moving on to the washroom. The washroom has a special treatment. So let's show you how we deal with the washroom. Okay. So first of all, there are two types of washrooms. The type 1 is the water cycle, washrooms with no tubs or showers. So that's called AWC, and the unique number of that washroom. So in this case, we don't have a shower or a tub, so we have to draw polyline. Since it's a polyline, we don't. We know that it's not automatically closed, so we have to select it, go to the properties, and close it manually. And now it's closed. We can use a PTA to transform it into a block. From the naming, as I said, this is a WC, and the other one with the tub, it's called TR, the bathroom with the tub. So this is a water cycle. We have to enter the block name. So A, WC, and dash, and let's name it. Let's see if that works. It did, and it's called now AWC01. Let's look at the attributes. The area is given. The height, we have it from the cross section is 2.62. The length is given. This is related to if we see the bathroom here, it is related to the unit. Like, it's not related to a master bedroom or anything. So we have to put the relationship to the residential unit. So ARU 01. Width is given. Is it mechanically ventilated? Now this is very important. This washroom doesn't have any windows, and it has to be mechanically ventilated because to comply with the Saudi building code. In order to do that, so we have to put yes if it's ventilated. I know that this washroom is ventilated, so I hit enter, and now we're done with the washroom. Let's move on to the stairs. I have to move on a little bit faster. So the stairs, how do we deal with this? We have to draw a polyline around it. We go all the way around, and we close that polyline. Select it, close it, and transform it into a block by writing PTA here. Oops, sorry. PTA. Yeah, perfect. And we call the stairs ST. So A, ST, and 0, 1. We hit enter. Just give me a second, please. Thank you for waiting. So yeah, we defined the block. Now, if we because we named it as ST01, now we have to fill in all the attributes. For example, for height, I know that it's a 2 meter height between any step and the ceiling. This is related to the unit A RU01. The riser we can get the information from here. It's 0.3, so we write 0.3. Does it serve an exit? This stairs does not serve an exit, so we put 0. Step count, we know we can count it. There's 10 steps here, 10 steps here, and a step in the middle, so there's 21 steps. We write 21. The tread is from here we can see it's 0.1509. Sorry, 0.1509, and the tread width we can check it from here manually. Maybe we can get the distance, or you can see that it is. Oh, something happened. 1 second. .04. So we go back, we select the stairs, and we write 1.04. But wait. No. Yeah. So we add it here to 1.04, and we are set with the stairs. We are done with the stairs. One more thing with Revit is the ramp outside. The ramp has to be defined again from the list. We can draw a rectangle here, transform it into a ramp. So we have to write PTA. PTA, select it A-RA for ramp from the list, and dash, and let BIM name it. Let's see what we got here. It named it as RA01. Now this is related to the land area and not the residential unit because it's outside. So it's 0, 1. The vertical and horizontal values, an elevation should be here. I know the elevations of this ramp. This is 100 and this is 100 and 100.3. So basically, if we select it, I know that the vertical is 30 centimeters, which is 0.3, and the horizontal we have to kind of check it. So we take the distance from here to here, and it's 6.48. We select the ramp, and we put 6.48. This way, BIM Lens will know automatically how to do the calculations. I missed a very important thing in the bathroom. Okay. So as I said, we named the bathroom as WC, but now we have to deal with the toilet. The toilet has a special treatment. So in order to get all the requirements for the toilet, all the code compliance points, we have to see if the toilet has enough space for a person to roam around the washroom, or for a handicapped person with a wheelchair to be able to at least go inside and outside the washroom. In order to do that, we have to define the toilet block. Toilet block is not defined by the toilet itself. We have to draw a rectangle here, and we have to connect it to all the walls that are in front and adjacent to that toilet. Not necessarily walls. Sometimes there's another fixture or another cabinet or whatever. So you have to select everything that's surrounding it. In this case, I have it here. So I drew the polyline. I write PTA. I hit PTA and I select the toilet, and the toilet is called a TO, and then give it a unique number. We see that it's ATO01. We look at the attributes. We find that we have to build relationships. So it's related to the washroom, which is WC01. And we have to specify the adjacent and front distance to see if it's compliant against the Saudi building code. So in order to do that, we have to check the distances from here to here. So this is a 0.47, and from here to the middle of the toilet, which is here. Let's move it a little bit so we can see. So we select the toilet block and not the toilet itself, and we have to add the attributes. Distance adjacent is 0.47, and the distance front is 1.54, and we're done. We go to the second floor and check out the washrooms there. As I said, we use a different name for the washrooms with the tub. So this is called like a bathroom in common sense, but the naming from the list is called ATR01. So we draw, for example, a polyline from here, going all the way here, 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 and here. We click enter, we select it, we close it, and we hit PTA. We select it and transform it into a block. So this is called a TR from the list for washroom or bathroom, and let BIMLens name it. Let's see if it worked, and yes, it's ATR01. We do the same thing for the toilet and the sink, and like we define them. For example, this is a sink. I have to give it a relationship and a name. Oh, sorry, not the sink. The toilet, we have to do the what is it called, the boundaries around the toilet. I'm not going to do it again. But in this case, we have a shower. The shower has a rule that has to have a certain area inside a bathroom, and there's another rule that's involved with it is every household or every residential unit should have a bathroom that has a shower. So we're going to take the area of this shower and create a block. So we know it's closed because we chose the rectangle option. We write PTA here. We select the shower, and we name it a BH01. That's from the list. I'm going to update the list. In the list, I think it shows SH, but I'm going to give the most updated guidelines, inshallah. We hit enter. All we need to know is to set the relationship. Relationship is A for TR01, so it's related to that washroom. The height is irrelevant, and that's pretty much it. We want to know the area if it's enough to comply with the rules. One more thing, I think I told you that since this window doesn't open, it's just a glass. So basically, we have to specify if it's mechanically ventilated, and in this case, it's one. So this is pretty much it for AutoCAD. I'm gonna jump into Revit. Revit, as I said, we do the exact same thing as we did in AutoCAD, but the thing is, we don't use blocks in Revit. We use spaces and rooms and relationships. We use the same naming conventions for the elements. We do relationships between spaces and spaces, and the relationships between spaces and objects and objects and objects. So let's start off with the same exact example. As I said, I'm not going to show you how to draw the structural part or the architectural part. Engineers should be able to do it, or drafters. I'm going to show you how to name the spaces and how to go further with the compliance check. So if we look further, if you select anything, basically this window, for example, look at the properties, you will see that I should provide it with an element ID and a related to, and because this is a window, there has to be an open area number that I have to put here. So basically everything else is automatically given. So let's start with creating rooms for this floor. So basically, I'm creating a room here. This is going to be called kitchen. This name here doesn't mean anything to BIM-Lens. It's just for professional use and to showcase where the kitchen is for any contractor or viewer or owner or any stakeholder. So basically now we defined a space. This space now has to have attributes, right? In order to have attributes, we have to name it. As I said, we named this in AutoCAD KI, and we're going to use the same exact namings from the list. We hit enter, and I know that it's mechanically ventilated. I check the box here, and we know we have to make a relationship. So it's related to the residential unit, but I don't know if the residential unit is already defined here or not. So I'm going to check, but anyways, I'm going to write the name. If we go to the site map, we can see that this is defined as CA, which is a compound area. I gave it a name earlier, so I named as CA compound area 01, and it's not related to anything or it's related to a city or a street or whatever. We go closer, we go and choose the land area. Land area, I already named it as LA01, and it's related to the compound area that it's in. Zooming in, we see that the next one is the residential unit, and it's related to the land area. In order to specify those areas, I used property line from massing and site. I drew a line and I gave it an element ID. This way, BIM-Lens will know where to look or how the relationships are built inside this model. Going back inside, so just a recap, I defined a residential unit, RU01, which is related to the land area, which is related to the compound area. We go to the architecture drawing level 1, and we go back to the kitchen. We look at the kitchen. We see it's given a name and it's a relationship with the residential unit 01. Now, to comply with the kitchen rules, we have to have a sink, so I have to name this. It's already given before, so I named it as ASI03. Now, there is no list file here in Revit. There's a template that's going to be provided to you guys. The thing is, it will not be giving any automatic consecutive numbering for any of the objects or the spaces. So you have to write in full A-SI, for example, -03, and you have to keep up with the sequence of the numbers. This thing is related to the kitchen. Now we built a relationship between the kitchen and the sink, and BIM-Lens would understand that this rule is compliant and it will check it as okay. Now every space has to have lighting and mechanical ventilation or natural ventilation or natural lighting. In this case here we have this window. We have to name it. It's exactly the same thing as AutoCAD, so the name is a WI. This is of type 2, I believe. No, actually, it's type 3. Yes, type 3. So the type here is 3, and it's, let's say, 01, or to just be in the safe side, we just name it 12. It's a unique name, so it doesn't matter. Now this window opens fully, so we know that it's 1.2 by 1.2. If we do the calculations, it's going to be 1.44. That's the area of the window when it's opened or closed, because it's fully opened. So the opened area is 1.44, and it's related to the kitchen. So A, KI, what did we name the kitchen? KI 01. So we go back to the window and we give it a name 01. Apply. And we're all set for the kitchen. This goes to all the spaces. For example, I want to draw a space here. Since this is an attached house, we don't have windows for the dining room. This space is for the dining room where I'm pointing with the mouse, but it's an open area with a living room. In this case, we can name the space as 1, which is called, for example, living room / dining room. As I said, Vimland doesn't care about these names. It's just for professional use. Now, if we select the space, I have to give it a special name, which is a LD for living dining and 01. It's mechanical ventilation, no. It doesn't, it's not relevant, and it's related to the residential unit, ARU 01. Now we have to check for the natural light and natural ventilation. So these are the 2 windows and the glass door that's there. We need to define them and set relationships with them. So basically this is already done. I know that the area of this window is a certain number, and this is the open area. It's opened by half, so basically I just calculate the open area, I put the relationships, and that's it for the window. This goes for all the windows. Now, again, for the washrooms and the toilets, this is a WC and not a bathroom. So we, for example, give it a name of WC. We go to rooms, we create one, and we name it as WC, for example. Now, when I select it, I have to give it a proper name. So from the list, it's a WC and 01. Since this washroom doesn't have a window, it has to pass the law or to pass a code, it has to be mechanically ventilated. So I know that it is, and I just check it, and it's related to the residential unit. So ARU 01. Simple as that, easy. Now the toilet, I select it. I give it an element ID. It's ATO for toilet and 0, and that's oh no, that doesn't work here. I remembered, so I have to give it a name. For example, 012, just to be on the safe side. And we have to give it a relationship, which is related to the WC, which is this one. Let's just check the name. It's WC01. So I go back to the toilet and a WC01. Now I build the relationships. Now the distance adjacent, this is in front. If you can see, I've already taken the measurements. So this adjacent for this one is 0.49, and this one is 1.57. Hit apply, and now BIMLANS would know the attributes for this space and how everything is related to each other. So it's pretty much it. Like there's nothing really much to it. Every space has to be named by a room. If you can't name it by a room, you go to the site, and for the areas, you can just name the areas. For example, here we have one more thing. There's a ramp for the entrance, and it has to be a certain slope. So basically, I drew it with a slope. The designer should know how to do this. I called it ARA02, and it's related to the, it's not related to the residential unit, it's related to the land area 01. And automatically, BIMLANS would know that its slope is 2 degrees, and it will check for its compliance. For the doors, as I said, it comes in four types. So this is 0, A, D, O, D's, O's, 0, 1, 15, for example, and it's related to the residential unit, so ARU 0, 1. But does it serve as an emergency exit? Yes, it does serve as an emergency exit, so I check yes for this one. So this is pretty much it. Of course, Revit is so much easier than AutoCAD. There's a lot of automation going on here. You don't have to manually input numbers. BIM can read it all just using our template that's going to be provided to you. You're going to be okay. So I would like to thank everyone. I took a little bit more time than I should, and I want to pass the microphone to Engineer Zaid. I would like to thank everyone again, and good luck. Thank you. Have a beautiful day.
Thank you, Engineer Bilal, for this comprehensive and brief guide for the procedure of making our design drawings compliance with BIM, the automatic permit engine. I would like to introduce myself first at all. My name is Zaid Al-Hawamdi, structural engineer with the BIM team. I hope my voice is clear for every attendees. I heard much complaints about the voice. We are suggesting and recommend you to install WebEx meeting app in order to hear us clearly. And I hope this guide lectures that we are working on with the workshops with you will help you to make a better understanding of BIM procedure, how you can make your drawing, knowing some methods for matching your drawings in the way that BIM can understand it and give you a instant review and permit on your drawings. We will start by thanking the Ministry of Housing and every engineering firm that we have integration efforts with them for upgrading the compliance engine to have the BIM version now. We will go through the structural drawings now. Hope it will be helpful for you. I will start sharing my screen. I hope it's clear for all. First at all, BIM and the way that he is thinking about with the Saudi vision and the Ministry vision is to make some standardized actions for all of the structural engineers, the draftsmen, to introduce and to present their assumptions and factors that they are working on their design in a standard way. So every structural engineer start his design for an entity or building or structural element. He has some consideration and assumptions for the loads, for the dead load, live load, the assumptions for the seismic load, for the earthquake, the wind load. So we are asking every engineer to present his information in a way that BIM can understand it and can present it clearly. So this schedules will be as a template. It will be sent for you to fill it according to our guideline. Before I go to the structural schedules, let me present the guideline that we prepare for any structural engineer to make matching between his drawings and BIM to have an optimal understanding and to have an instant permit for his drawings. In this guideline, you will see here is the list of content. There is some introduction, the terms and the terms that we are gonna use, the structural rules. Here in we all of us know what's the meaning of solid slab, ribbed slab, whatever. You can read this clarification for these terms. The things that we should care about and to focus on it, the rules that BIM that are focusing on. We are classifying each member or each structural element, the rules that are related to. So here you can see the structural columns, the structural slabs, the rules that that we must obey for it and we must follow in order to get our permit, the structural beams, structural walls, foundation, rib slab, the load combination and structural analysis rules that Ministry of Housing and the Saudi divisions is pushing and telling each structural engineer and engineering firm to follow the Saudi code, the SPC, for the loads, dead load, live load, the earthquake, and the wind load. So you can see all of the rules that we are following and checking. At the end, oops, let me open the other version in order to see the naming criteria that we should follow. Where it's being class. Here's two. So as engineer Bilal said, that we must follow some element criteria in order to let BIMLens know what we are naming and have the rules to be obeyed on it. So we have a structural beam. Our element naming should be start with S for structural, SB for, it's a name, a short name of the same element. We try to make it as much as easy that we can in order to make some relation between this naming and the structural element. So the structural beam gonna be SB. For a structural column, it will be an SC. You can see it's just some short relation between this name and the real structural element. Let's say for footing, if O, for the slab, if we are going to one rib slab or hordi, as the Saudi code said, you can see OH, one way, two way, it's gonna be 2H, one way solid slab, it's gonna be OS, TS for two-way solid slab, and you can see all of these structural name and criteria that we gonna follow, inshallah, in our design and our drawings to make it matching with BIMLens. So I'm gonna go back to the schedule that we are asking for the structural engineer to fill. First at all, he should make some naming for the structural levels. If we, for the first, let me say that we should integrate or should be define a structural level for each structural level that we're gonna use. In foundation, maybe the foundation will be in many levels according to the land conditions. So what we're gonna use, as Engineer Bilal said, first at all, I'm gonna take the list file. The list file can be added in several ways, but the most and the easiest thing and the way that I recommend for you is make it drag and drop and easy like this. You can use an upload command to load it. You should just map it and press load, but I prefer the first one. The first step, I should define the structural level in each level. Here we are dealing with a simple villa. Your project can be in much levels, so you should name each level that you are working on it. We can define it to make it a rectangle on the land area, or let's say a project part. Let's say from here to here, we're gonna be in a project level. So I'm gonna define this structural level, and I use the command of PTA. Look, you can, after we are dragging and drop the list file, you're gonna find this command PTA. I select it and select this polyline, closed polyline or rectangle. and he is asking me to put the structural naming element, as we said in this table. I will add a structural level. The structural level gonna be as S for structure, SL for structural level, and the third part gonna be the building name or the building number. Here we are dealing with building number 1, and I gonna put the number of the level that I gonna use. Let's make it 15 or 00. You can do whatever you want, and but you should follow this naming later on. So I already defined this structural level. The structural level, it will be S from structure, SL structural level, 01 the building 01, 00 the number of the level. After that, you will defining all of these levels, and you're gonna use it here in this table. Here in this table, we're gonna define the dead load and live load for each structural level or for each slab that we're gonna use in our project. So you can here define a structural level, or you can define a slab that you already defined previously. So first of all, we're asking the structural engineer to define his dead load and how he counted. So the first term that we're gonna define is the filling material, the filling density, the depth of this material, and the total load coming from this filling material. It's gonna be helpful for me and for any engineer coming later on for checking the project and making any adjustment or any modification on this building. He gonna go back for the first design assumptions, what he used in his calculation, the filling type, material, the density, the height, if he gonna use 2 levels. So, and he noticed that the engineer, he only counted 150 millimeter sand fill, and he wanted to make 2 levels. He clearly and couldn't make the fill 300 mm or 400 mm, and we recommend, or he will recommend, to make a raised floor system in order to reduce this dead load and following the design load that the structure has been executed according to it. After we are defining the filling type, we are going to defining the tiling type. Here the engineer should put and define the tiling type that he gonna use. Here they define the marble, what's the load coming from marble, the total load, the partition that he gonna use, what's the depth, what's the material of this partition, is he willing to use a gypsum board partition, glass partition, or he gonna use a hollow block partition with plaster. So we are asking the structural engineer to define the type of partition and the thickness and the load coming from according to the Saudi building code. The fourth thing that we are asking for, the ceiling type that he gonna use. Here the structural engineer defined that he is gonna use ceiling type from gypsum board. The thickness of gypsum board is 12 millimeter. The loads coming from gypsum board is, according to this table, is 0.096 kilonewton per meter square. At the end, we are asking the structural engineer to put the allowances for the mechanical installations. If he are using a centralized HVAC system, heating, ventilation, air conditioning, so he should put the allowances for this ducts load gonna be handled for the slab. And if he is having if he has a sprinkler system, to put the allowances for this type of system. The total dead load will be count the summation from these all totals coming from this table. This load I gonna compare, or the BIM gonna compare this load according to the loads that are applying on the ETABS model. We forget to tell BIM he is supporting the files coming from AutoCAD, PX file, and come from Revit, IFC, and linking it to the original structural model and analysis application that we are dealing with in this version of BIM is ETABS. So we are gonna learn how to match our AutoCAD drawing with the ETABS and our model in Revit with ETABS. So this load gonna be compared with the dead load that assigned to the ETABS model in each slab level or each structural level. The second table that we are asking to fill the seismic load factors coming from earthquake assumptions that structural engineer used for his design. If he is referring to a soil test, we are asking him to put the reference of soil test, all of the assumptions or the factors, seismic factors that applying on our design, the long transmission period, TL, the S1 and SS, the acceleration coefficients for the ground coming from any expected earthquake. And the last one is the E, the site class. He can use the seismic map, or he gonna referring for a soil test that he give him these factors. And according to his assumptions and to his design, we are asking him to put to us clearly the factors coming from his design theory. Is he designing a steel structure or reinforced concrete structure? He and shear wall structure. He should give me the R and omega CD importance factors to be filled here, and the BIM lens gonna compare these factors with the ETABS model. The last assumptions schedule that we are asking in this phase of BIM lens is the wind load factors. According to the wind speed map in Saudi Kingdom, we are asking him to put the wind load or wind speed that he is gonna designing according to it in mile per hour for sure, the exposure type, the topographic factors, the directional factor, gust factor. He should put all of these factors. These factors are gonna be checked by the code and to be checked matching with the ETABS model. After we are finishing our design, each engineering firm present his design in many ways. Some of engineering firms presenting their design using tables. Some of them make some longitudinal section showing the steel rebars in each part. Some of them put bar bending schedules. We are allowing the engineering firms to make whatever they want to present and deliver the work in the quality that they want, but we are asking them to put the result of this design in a standardized way. So we are asking them to put each type of column, foundation, slabs, beams in a such way that can BIM lens read and compare these results with the ETABS. So we are giving them schedules to be filled with foundations, schedule, foundation types. Each foundation that he is using in the project, he should put the type, the length, width of each type, the depth, the reinforcement for each type in the long way and short way, the upper and lower, the top and bottom reinforcement. So these criteria will decrease the work on me for putting all of these attributes or of these parameters later on in each foundation I gonna define for BIM lens. If I go to the foundation plan and I make some expedite step to check and to make you to know to let you know how much it's gonna be easy for me filling this table. and what is the parameter that I can pass it without repeating again and again for each foundation. For the first line of the foundation, foundation number 1, I am defining the foundation number 1, the first one. So I define it using PTA Lesn file, PTA command coming from Lesn file, and I am naming the foundation in 4 digits. For S from structural, foundation FO, 01 the type of foundation, and the last one the serial number of this foundation. Make it by this naming way, I can make link between this foundation and the type that I defined previously in the schedule. I don't have to repeat all of the repeated and defined parameter like the length, width, depth, but here we define it already, or the depth and width gonna be automatic defined from the list file. Related to, I gonna put it the structural level. I will go back for it, the height. So the reinforcement, I did not put it here again. The BIM lens gonna take it from the schedule, and I pass this step to make my work more easier than it's gonna be look like later on. After I define the foundation, I should define the walls. This is the wall schedule. I should define the wall type, width of each this type of wall. This wall type, the width is 200 mm or 0.2 meter. The vertical and horizontal reinforcement. I go in the next. If we go to the next schedule, for the column schedule, you're gonna see the structural column, width and length for each type, the main reinforcement, and the stirrups reinforcement. Beams schedule, you can see here the beam schedule, width and thickness for each beam, the top and bottom reinforcement for each beam. The last schedule that we are asking the structural engineer to fill for us and define it for himself, the beam schedule, as we say in our previously element ID naming criteria. For each slab type, I have a different naming criteria. For one-way Hordy or one-way ribbed slab, I should define the ribbed slab OH. If it was one-way solid slab, I should define it in OS. If it's as a solid slab or flat slab, I will define it SS. There is other type of slabs for water tank slab or for two-way Hordy or two-way ribbed slab. I should name it by TH, or two-way solid slab, I should name it by TS. And we are asking the structural engineer to put and define the thickness of these slabs, the ribbed width, rib spacing. The first 6 columns is related to the ribbed slabs. If it was in one-way or two-way, so he will define the ribbed width, rib spacing, top reinforcement, bottom reinforcement, solid layer. This solid layer slab that's gonna be placed above these ribs, and its reinforcement. If the naming element ID was the OH or one-way Hordy or Hordy slab, the BIM lens is gonna take these numbers. If it was OS, you just make it empty, don't put anything, and the BIM lens we're gonna take these parameters or these attributes from these cells from the schedule. Here you can see that these columns is related to the slab top reinforcement in X direction or Y direction, the bottom reinforcement in X and Y direction. And lastly, we have to define if the slab is supporting any architectural element that's gonna be affected by deflection or large deflection. It's gonna be sensitive so that it's gonna be handled in other way, in other limits, So if this is a Boolean expression, so if it was supporting an architectural element, sensitive architectural element, you should put 1. And if you are not supporting any architectural or sensitive architectural element, just put it at 0. You can put it here or in the drawings. The priority will be for the attributes that manually assigned or defined in the drawings. So if you are having a slab and the part of a slab has some special case or a sensitive, more sensitive criteria to be designed, just add it manually on this element. After we finish all of these schedules, this schedule will be repeated in Revit later on when we go through Revit discussion or lecture or workshop part. We will go now for the foundation. We previously talked about how we're gonna assign or define the structural level. Then I will start defining the foundation. BIM-Lens can be dealing with many AutoCAD files. So if you are making some external reference and defining the foundation in one layout and or one AutoCAD file, the column in other drawings, only what we have to do is defining these structural elements on its own AutoCAD file or on its own layout, and just make DXF for each structural element and make sure that you are uploading it on BIM-Lens as engineer Bilal show us the user interference and how you could make this upload for these drawings. After we define the structure level, we will start defining the foundations. This foundation is rectangles or in a rectangular shape. Some of them are square, some of rectangle. So the rectangle lines or rectangle shape will be the easiest way to be drawn in this drawing. So if I want to define this foundation, I should make a rectangle, or I can make it by a polyline, but I have to make sure this polyline is closed. Just put a closed yes, and take the PTA command, select this polyline, close polyline, or rectangle, or whatever it was, and put the element ID that we talked about as per the naming criteria. This is a foundation, so I should start with S for structure, foundation FO, and put the type to have a link with the schedule, to take some parameters from there, and to put a serial number for this foundation. If I like to put it manually, the serial number, I should make and memorize the last one that I named. If I want it to be in sequence, not a random. If I wanted to have an automatic serial number, I just have to make it after the last dash, to make it without any additional number, and the list file will give me a random, or not random, automatic serial number. Here he gives me a 04. I already previously defined this foundation. This foundation is named in S for structural, FO for foundation, 01 for the building, 02 is the serial number of this foundation. Some of these attributes has been calculated automatically from the list file, the linked width. Here I should put the related to. This foundation should be related to the structural level. So the structural level for this foundation is 00. The structural excavation depth, I should put the height. I can put it here automatically, or I can take it from the schedule. Here we already put it manually. The excavation depth, here I should put the excavation depth. I use it at 2 meter depth. For the reinforcement attributes, I leave it empty, so BIM-Lens will take it from the schedule. And the last thing I should put the cover. The cover here is 5 centimeters. And I will repeat this procedure for each foundation. Let's see, here is a foundation of type 2, the serial number is O2, and I should put this all these factors. The length and width were gonna be calculated automatically. As we know, the AutoCAD is having 2D point of view for these drawings, so the length and width will be gonna be easy for each element. The hardest way, or the thing that we should put it manually, is the height. Relation, I should put the relation with the structural level, excavation depth, and the cover type. After I finish the foundations, the naming, I will go to the vertical structural element. We will start by the columns, and as we said, if you are using many AutoCAD files, it's gonna be okay. Just make it for each column axis. Some of columns will continue for all of the floors. Some of these columns are gonna be stopped for some extension or decreasing in the project floor area. Some of the column will be planted to be and to show in other floors. So I should define the columns in each structural level. I have it. So I will start my work by the level 00. The way that I should define this column is using a rectangle or using a closed polyline. Using the command PTA, I select this rectangle, put the naming ID S from structural, SC structural column. The type of column, this I have it as 01, and I should put a serial number for this column. I can make it manually or automatically. If I want to make it by list file, just leave the space or leave it empty after the last dash. Here I make it. He gave me around automatic serial number is 36. I already defined this column. We can go this for this naming. This column has been defined as S from structural. The name of this column, S from structural, SC from structural column, 01 for the building, 01 the first column that I have defined in this project. I can see these attributes that I can take it. The length and width is gonna be taken automatically from the plan. I should put a relation with the structural level. For the reinforcement, I can make it here. I put it here manually, or I can referring to the schedule that I already previously defined. The last thing is the label. The label is the way that we can link this column in this drawing with the column has been defined and the analysis came through on it in ETABS. So the label here is C1. I'm gonna go for the ETABS model to see it. This is the model of ETABS. We are talking about this column. As you see, the column has been defined as a C1, and the story structural level, we are named it as the same way that we name it in AutoCAD. So the label here that we should put is C1. In this stage of or in this phase in BIM-Lens, we will make it this manually. Later on, we are working to make it automatically, to make the link between these columns and the model. And after I finish this column, I go to the next column, the third, the fourth one, and make sure to put the label as per ETABS. There is one thing in ETABS can make my work is easier. The column, if it was a replicated column, go through all of these floors. The labels, as you see, it's gonna be the same. So in order to make the work is easy, to name the columns in the same place in all of these floors in the same one shot, just put it in one way. Here I can make C1, and it's gonna take this name for all of these columns with one label in one shot. After I finish the column in each structural level, for this one, I should referring for the structural level that this column is be executed on, or gonna be executed on, or designed to be on. After I finish with the column, I will go to the second vertical structural element, which is the structural column. I will define it in the same way, just make a rectangle from the edge to the edge, put using command PTA, selecting this rectangle or the closed polyline, put the naming element ID or element naming criteria S from structural wall. It's gonna be SW, the type 01, and I should make a serial number for this wall, or let the Lesn file to do it for me and to give this wall a automatic serial number. Look, I let the Lesn file to do it. He gave me 13 as a serial number for this wall. I already defined this wall. This wall is from structural, SW from structural wall, 01 from building name or building number, and 3 is a serial number for this wall. Here you can see the attributes that we need, the height related to the height. You don't have to put it since you are relating for the structural level. The thickness is gonna be counted automatically. The label that I have to put it manually and to get it from the ETABS. Here you can see the label is W1, so we define it as a W1. After I finish this wall, I will repeat the work in each levels, and each wall can be continue from for all of these floors. Some of walls gonna be stopped, some of walls gonna be planted or as a column. We should define the column in each structural level we are dealing with. After I finish these vertical structural elements, I will go to defining the horizontal structural element. The first one, I gonna define the beams. These beams or these structural beams will be defined the same way that we learned to do, is to make it from the center of the column to the center of the next column, or to have precise length for these beams. I will use the command of PTA, selecting this rectangle or closed polyline, putting the element ID or the element naming S from structural beam is P. The type of the beam that I previously defined is 01, and I should put a serial number for this beam. I can make it and I can define it manually, or let the Lesn file to do it automatically. I will let the Lesn file to do it automatically. The Lesn file gives me a 35 as a random name, or not a random name, automatic serial number. I already previously defined this beam, and the Lesn file gave me a 09 as a serial number for this beam. As we know, some of these attributes will gonna be calculated automatically as a length and width for this beam. The height of beam I have to put it manually, or to give a relation from the name and gonna be taken from the schedule automatically. Here I put it manually, 0.6, the height of this beam related to the structural level. The structural level here is 01. Supporting, if it was supporting an sensitive architectural element that gonna be affected by large deflection, I put up 1 as it is a Boolean expression, and 0 if it was not supported any sensitive architectural element. The top and bottom reinforcement I can put it here manually. Here we already define it as T, thickness 16 millimeter, 2 rebars with thickness of 16 millimeter, and the bottom is T, thickness 25. The type of the beam as we know, there's 4 types of structural beams. The type 1 is a simply supported beam. The type 2 is one end continuous, like this case of the beams. This beam is continuous from one end, and the other one is stopped here. So we give it a type 2 for one end continuous. Type 3 for the both end continuous. If the beam was continuous in two phase or 2 places or 2 ends, has continuity with other beams, so we put type 3. If it was, and this case we don't have it, we did not have it in our project here and our sample. If it was cantilever, has a non-supported edge for this beam, we put the type 4. The last thing that I should define is the label. The label I can take it from the ETABS. The label here for this beam is B1. So I should here define the label with B1. After I finish for all of these beams, I will go for the floors, and I will follow the same procedure. The floors can be defined using a polyline, closed polyline, and I take it from the center of the columns and center of beams, and use the command of PTA, selecting this polygon or rectangle shape or closed polyline, and put the structural naming. This slab, as I see, is a solid one-way slab, so I would put it OS, one-way solid slab, the type of 01, and I will let the list file to give me automatic serial number. He gave me already 05. I already defined this slab as a 03, and you can see all of these attributes. Some of them will be calculated automatically from list file, and other I should define it manually. If I define it manually, it's gonna have a priority from the information that could be taken from the schedule. If I let it as NA or an empty space, the beam length will take it automatically from the schedule. And the last thing that you can see the related to, I should put the relation with the structural level, the thickness of these slabs, the supporting, if it's supporting any sensitive architectural element, the reinforcement in the 2 direction both layers, the type of this slab. This slab, as we see, it's a one end continuous slab, and you're gonna have the same condition with the beams. So I put the type 2. The label, I should have it from, if you are talking about this slab, the label that we are talking about is label 4, F4. So we should put F4. And after I finish the slabs, I will go to the other slab, the third slab, for all the levels, and finish my project in AutoCAD, save it as a DXF, put it in the outbox, and wait a second. We should have a quick look for the model in ETABS. As we said, the materials that we define should be, as we will see in the rules, should be according to the Saudi building code, from the compressive strength and yield strength for the steel, for the slabs, for the frame members. You can see this the structural columns. It should be using these approved or the structural materials that following the Saudi building code recommendation, and the modifiers that we using for these columns gonna be 0.7 as Saudi building code. So beam length is checking the modifiers that we already define in each structural element we use in our model. For the column and for the beams, we will go for the slabs and the walls, checking the materials and checking the parameters. If we go for ribbed slab, and having some link between our drawing and our model in ETABS, he will checking all of these dimensions, all of these parameters for the depth, rib width, rib spacing, everything will be checked between the model and between our drawings. After we finish these checks for slabs, walls, frame sections, we should check our load pattern assumptions. We should define the dead load, and here we define it in a two-way, one for the dead, one for super dead. The dead having the self-weight multiplier by 1, the super dead has a self-weight multiplier by 0, and we can assigning the imposed load from the partitions, from the fill, from the ceiling, mechanical installation to be assigned in super dead or dead load that BIM is going to be checked. Here you can see the load pattern that I already defined. These factors should be as per our assumptions in the table that already has been defined, and the wind load should be as per the schedule that we previously defined. The last thing that we should check before making our analysis and exporting our E2K file from the ETABS is to checking the load combination. In Saudi building code, we have 7 loading combination we should follow. If you want to increase more load combination, we don't have any objection. Just put these combinations that we're asking about as per Saudi building code. Here you can see the most common load combination all of structural engineers use is 1.2 dead, 1.6. If we want to check the dead load, you can see the dead load here is defined 6.5. We previously defined it as 6.2 or 6.19 in our schedule. If it was equal or greater than what you calculated, it's gonna be passed. We will use analysis and structural concrete frame design and make the export procedure. Export an E2K file and export a database text file. Put a tick here in design output. If you make the design and make the design for the concrete, you will be a concrete design output. Just put one tick on it and export this database file for me in order to check the reinforcement, the loads, the assumptions, the analysis that we did in this model. Excuse me for our limited time for this workshop. I will go quickly on our ETABS model. As you see, the ETABS model will follow the same steps and the procedure that we follow in AutoCAD for the schedule. The schedule will be sent to you in a template. This template will contain the schedules, will continue the parameters that you should define for each structural element. You can see here's the loading schedule, the beam schedule, column schedule, wind load schedule, seismic load schedule. If I will go back to the model, here, as we know, some of engineering firms is using multi-disciplines, multi-work sets, multi-teams. Some of the teams was working on the architectural and some of the teams working in structural, other in MEP. So we can make several IFC files for each discipline and upload it in one shot in BIM, but just make sure that all of these exported IFC gonna be uploaded one shot in BIM to have full compliance and full permit, inshallah. Here I will make a hide for this architectural element. Here I can see the structural building. We can see these footings, beams, columns, and you can name it using the parameters that already defined. this parameter for element ID, I should define the foundation type number, the relation with the structural element. If I take another example for the structural, you can see here the structural column name, the label that I can, I should take it from the ETABS, the length and width, the main reinforcement. I can manually define it or take it from the schedules, and related to the structural level. For the beam, in the such way, just define the element ID, the label from ETABS, the relation in structural level, the type of this beam, as we said, one end continuous, simply supported, continuous, and so on. The last thing, excuse me if we pass our meeting time or workshop time. The last one is for the flooring. Just put the element ID, the label coming from ETABS, the relation between these slabs and the ETABS by label. And after you finish all of these steps, just make the export step. You can find it in our guideline exported IFC file. Just make sure the IFC type is IFC for reference view, and the property sets to be has taken all. You have to put tick in all if these text and define, and you should take this one text file that we're gonna give it to you, map it and browse it here. Just make OK and make the export for this IFC. Put it in one outbox file with other disciplines like architectural IFC, structural IFC, MEP IFC in the later stage, with the ETABS E2K. Upload it in one shot for the BIM lens to have compliance and having the check automatically. This was a quick, comprehensive, and brief guide for the procedure of making our design matching with BIM lens. I hope it could be helpful for you to make a sight and a vision in the theory that BIM lens follow, and we can have better procedure to make a good experience in permit design and approvals. Engineer Tamer will send you a survey. We hope you fill it with your opinion, with your fresh eye vision, to give us your feedback, to put your information, to give you a username and password for BIM lens, and to try it in your hand, inshallah. I hope we did not have such much time for answering the question. All of your question will be answered and sent to you by mail. If you have any questions you want to ask later on, just email it with the email provided by Engineer Tamer. Thank you for your time, and if you wanted to have another sessions, we have other sessions in today, which will be in Arabic, and we will have another one in English. I guess it will be from 4 to 6 p.m. Thank you for your time and your valuable time. Thank you.